Hello everyone, I'm Moshir Rahman, and today the topic for this video is component diagram. So we'll be looking at what component diagrams are, what elements are there in a component diagram, and finally we will look at some use cases and some examples of component diagram. So what actually is component diagram? So component diagram is a type of UML diagram which actually describes the dependencies between each software components. So by software component we actually mean different parts of a software which can act individually or which perform a specific set of functionalities within the system. It is also we also use it to model the physical implementation of a software. It's also used to model the high level software components and their interfaces. So basically we design how the software components interact with each other through their interfaces within a system. All these representations are shown in a component diagram. We also get the static implementation view of a full software system through these component diagrams. And finally, component diagram is a type of UML diagram which is a structural UML diagram. So it actually falls under structural UML diagram type. Okay. So a component is basically a modular unit within a system, and it has some well-defined interfaces. So by interfaces we actually mean it's providing some functionalities to its environment, and it's providing those functionalities through its interfaces. And each of these components are autonomous unit within a system, and it has one or more provided and required interface. So provided and required interfaces are two types of interface, and we will cover that later. And its internals are encapsulated, hidden, and inaccessible. So it basically means that where the internal implementation of each components are hidden from the user. So component basically acts as a black box, and it acts as a black box so that we don't need to worry about the internal implementation. We only worry about the each components and their functionalities provided. And its dependencies are designed such that it can be treated as independently as possible. So we design each component in such a way that that each of these component can be replaceable, and whenever we replace this component, it's not going to require us to change the whole system or whole software. That's how the each of these components are designed. And the components can be a database, a user interface, or a hardware component such as circuit, microchip, or device, or a business unit such as supplier, payroll, or shipping. So it can be anything. It can be anything within a system can be a software component. So it doesn't need to be only some pieces of code, but it can also be chip, circuit, device, user interface, database, or even business units like supplier, payroll, or shipping. So any of this can be treated as a component. Okay, now let's look at some component notation, how we represent each component within a system. So in the first type of notation, there is a rectangular box, and within the rectangular box there is a stereotype, and this is called a stereotype when we write something within two angle brackets, and underneath that there is the name of the component. So there is the first type of notation. The second type of notation, there is a component icon and the name of the component, and in the third type of notation there is the component stereotype and the component icon. So stereotypes are basically the stereotype basically represents the type of component we are talking about, and there can be each component can be labeled with multiple stereotypes. So other types of stereotypes are entity, subsystem, table, library. All these are different types of different stereotypes. Okay, so we can use them alternatively, or you can use multiple stereotypes within a component to describe the type of the component. Now let's look at the component elements. So there are mainly four elements of a component, and these four elements are interfaces, usage dependencies, ports, and connectors. So interfaces basically represents a set of operation and obligations. Usage dependency shows the relationship in which one element requires another element. Ports represent interaction point, and connectors represent the connection between two components through interface. So we'll be looking at each of these elements in detail in the next slides. Interface defines the behavior of a component. It defines what functionalities a component can provide or what functionalities it may require from other components. So it's basically a set or collection of operations that it can provide to its environment or it may require, and the implementation is normally provided by another class or component or the component itself, because in the interface there is actually no implementation going on within the interface itself, but the implementation actually happens within the component or another components. So in complex system, this implementation may be provided by multiple components rather than a single one. So there are mainly two types of interface. One is provided interface, another is required interface. The provided interface basically defines what services the component or what functionalities the component can provide to its environment, and it has a ball notation, and it is labeled with a name on top of it. So for example, this order component can provide order entry related functionalities and account payable related functionalities to its environment, which other components can use. And for required interface, by required interface, the component actually defines what type of services or functionalities it needs from another component. So it is defined by it is labeled with a name and has a socket notation, this bracket like notation, and the interface that it requires is labeled on top of it as well. So when two components or classes provide and require the same interface, then these two notations are combined. So basically when one component is providing an interface that another component requires, then they are combined together, and the label or the name of the interface is written on top, just to mean that they are providing and requiring the same interface. In a system where there are multiple components, we represent like this. Here we can see that there are multiple components on the right side, which is providing the same interface that is required by the manager component, and the manager component will decide which component to receive the implementation or the functionalities from during the execution or the runtime. So it is defined during the runtime. Now let's look at usage dependency. Usage dependency is basically a relationship where one element may require another element for its full implementation. So it's basically when we import a package or a library within our code. That's when that's how we represent the usage dependency, or that's what the usage dependency represents. That a piece of code or a part of a system or a component or a package may require another package, and in that case we use this type of dependency, and the notation is given by this dashed arrow, and there is a label on top of it, what type of or what relationship it is, and that's how it works. And over here, as this is showing, a web shopping package uses a payment package. So basically when we are using some external APIs or libraries or payment gateways or anything like that, that's those type of dependencies are shown by usage dependency element or by usage dependency notation. Next, next a port basically defines a distinct interaction point. So through a port, the internal component or a component can communicate or delegate its functionalities to its environment, or an external component can provide some functionalities to its to some internal components. So port basically is a gateway for internal components and external components, for each of them to communicate with each other. Ports may have visibility. When it's drawn over the boundary of a component, it means that the port is public, and also means that all the interfaces that are connected to that port are also public. And when it is drawn inside the component, then it is either protected or private. So this is an example or a figure where we can see the implementation of a port. So here is a port. The notation of a port is given by a rectangle on top of the component boundary. It may be here or it may be inside as well. And through this port we can see that there are some internal components. For example, this safety inspection component is providing its state interface, or it's providing a state interface, and this provided interface is being delegated, or it's being passed on to its external environment through this port. And that's how the state interface is being exposed to the external environment for external components to use this interface. So similarly, it can also expose some required interface as well through the means of a port. Now let's look at connectors. Connectors may be two types. One is assembly connector, another is delegation connector. Assembly connector is, we have already looked at it. Assembly connectors are basically the ball socket notation, where an interface requires and another interface provides the same and a component requires and another component provides the same interface, and they are joined together to form through an assembly connector. So this is an assembly connector, and this is a ball socket. This connection is called a ball socket connection. And for delegation connector, okay, before that, let us look at, in case of multiple connections, this is how multiple connections are represented. There are multiple components, and each of them provide a certain interface which another component uses. So that's how multiple components actually provide or require same type of interface. And for delegation connector, this is how an interface is exposed to its external environment through the port. So basically, through the connector actually forwards the signal from the internal component to the external one through a port. So this is the port, and this line, the line through which the interface is connected, this is a delegation connector. So basically, delegation connector exposes the internal interfaces of a internal component to the external environment. So that's how it works, and it must only be defined between used interfaces or ports of the same kind. So basically, whenever this connector connects two interfaces, then the interfaces must be the same. For example, the safety inspection provides a state interface, which is then connected through a delegator connector and is exposed to the environment, and the external interface that is exposed, that is also the state interface. So it cannot be something different, like one is state, another cannot be something other than state. So they must be the same when it is connected through a delegation connector. Next, we have dependency relation. So we have already covered four main types of element, and this is another type of relationship that may exist in a component diagram. So in this type of relation, it's basically showing that a component is dependent on another component based on data. from another component. So for example, over here the customer component is dependent on online shopping component on data from the online shopping component. So online shopping component, or it is a database, and from this it's passing on data to the customer component, the order component, and these two component depends on the data from this component. So in such cases we use this dependency relation, and it is different because this is not something like we are importing anything, or we are connecting to external library or something like that. It's just we are requiring data from another component. That's why they are connected to this relationship. um, let's look at another example. Over here we can see that the account component is providing an interface called account detail, and order is component is providing an interface called payment. And this account detail interface is providing data to the payment interface. So basically this payment interface is dependent on this account detail interface for through the data from data, because whenever the order component needs to process a payment, it needs to get the account detail from the account component. So that's why it has a dependency relation with each other through this required and provided interface. Here is some of the use cases of component diagram. So we use component diagram to model the components of a system, to model source code, to model executable releases, to model physical databases, or to model adaptable systems. So component diagram may be used to model all of these things, and the main notation remains the same for each of these implementation. Just the type of components, or the stereotype of the components will just vary based on the type of implementation we are doing over here. Okay, so now let's look at a very simple example of component diagram of a component diagram. So let us think about Foodpanda. So what Foodpanda does is basically it connects the restaurant to its customers through a online platform, right? So Foodpanda is providing the online platform, and the restaurants are providing all the foods and orders, and the customers are ordering through Foodpanda. So if we look at it from a very high level, then we can actually model three components over here, three major components. One is the restaurant, there is the Foodpanda app, and finally there is the customer. Okay, so let me label them. So this is restaurant, this is Foodpanda, this is the customer. Okay, so there are three major components over here. So let us think about how Foodpanda works. Foodpanda basically takes the order from the customer, order details from the customer, and then it conveys that order to the restaurant, or places that order to the concerned restaurant, and then the restaurant processes that order and finally delivers it through the delivery boy of the Foodpanda, right? So so if we look at the interfaces that Foodpanda is providing, so they're actually so what does Foodpanda provide? So first of all, Foodpanda is providing providing a customer detail interface and order interface for the restaurant. Okay. Alright, and let me label the interfaces. This is the order interface, and this is the order details. Okay, now so order detail interface is actually so Foodpanda is actually dependent on the customer, on the data provided by the customer, because the customer actually provides the order details data through the UI. So basically customer is providing the order detail, so the relationship actually goes like let me show. so so we actually use a dependency relation over here, because Foodpanda is depending on the customer, on the data from the customer, the order details data. It needs the order details data from the customer, right? So whenever it gets those order details, it finally provides that order to the restaurant. Again, the restaurant can process food, but in order to process those food, the restaurant needs to have the orders, right? It needs to have an interface to get the orders. So restaurant, basically what it does, it basically requires an order interface in order to receive those orders. So that's why there is a required interface, which is also an order interface, and that order interface is required for the restaurant, and Foodpanda is providing that order interface to the restaurant. And through the order details interface, it's getting the data from the customer and passing on to the restaurant. So whenever the restaurant so basically what the restaurant does, the restaurant basically processes those orders, update the order status, maybe either it's cooking or not, or if it is cancelled, or whether it's already on the way to delivery, right? So if we look at a very simple example, this is a very simple example of a component diagram where Foodpanda provides two types of interfaces. The restaurant actually requires an order interface, and which has been provided by Foodpanda, and the customer is providing the data to Foodpanda, right? So this is one very simple example. Now let us look at some more examples of the order processing system, of another order processing system. So okay, so over here, as we can see, this is an example of another order processing system, and this is an order processing system component diagram over here. Okay, so let us look at the components. So first, there are mainly total there are 5 components over here. One is storefront component, order processor component, customer service component, analytics component, and the shipping component. So storefront component basically provides the order and the product details interface, and the customer service also provides the order and order override interfaces. So order processor component actually deals all the operations related to an order, right? So this is the part where all the orders are being processed. So it requires all the order related interfaces that the system will provide. So that's why there are total 3 types of interfaces, two types of interfaces that this order processor component requires. One is the order interface, another is the order override interface. So and that those interfaces are provided by the customer service and the storefront component. And again, the customer service component needs the product detail interface in order to because the customer service would be able to manipulate the product details. Maybe they can add, delete, or change the product details of a product. So that's why the customer service requires the product detail interface to perform those operations, and the storefront is providing the customer service component with that. Again, the shipping component requires the shipping order related interface, and the analytics component requires the customer data customer data interface, which are being provided by the order processor, because whenever this component is processing the order, it has actually the information related to the order, and it is providing the shipping information or the order which needs to be shipped. It's providing on those functionalities to through this shipping order interface, and this interface is again required by the shipping component. That's why they are connected through an assembly connector or the ball socket connector. And the analytics uses the customer data provided by the order processor to generate different types of analytics, or different types of graph, uh, uh, or different information related to orders and customers. Okay, so that's how this whole system actually works together. And this is an order processing system example. Now let us look at another one. Here we can see a nested component structure where actually there are multiple components within a single component, and and some of the components are requiring some interfaces from some external components. So through the ports and the delegation connector, they are extending those required interfaces to, or exposing those required interfaces to the external environment, and some other component may provide those interfaces that they require. So here is another example of a component diagram. So over here there is a web store component, a warehouse component, and an accounting component. So your warehouse and accounting are basically business units or subsystems over here. Web store is another business unit or subsystem, as we can say. So each of these components has some internal component, like search engine, shopping cart authentication, and the warehouse has inventory component within it, and accounting has order and customer component within that subsystem. So over here, if we look at the search engine component, for a search engine to work, it needs to it basically provides the search functionality to its external environment, and in order to complete those functionalities, it needs to do an inventory search. It needs to be able to search the inventory for that. So it requires a search inventory interface from some other component, and that is being provided by our inventory component over here. Again, our authentication component provides the registration and login functionalities to its external environment, but in order for it to provide those or work properly, it needs to be able to manage the customer. So it requires the managed customer interfaces, which are being provided by some other component. So by the customer component, it provides the manager customer interface to the authentication component. So basically that's how each of these components are interconnected to each other. Whenever someone requires some functionalities, it basically shows it through a required interface, and another component is providing that through a provided interface. So that's how the connection happens between each of these components. Now let us look at model view controller design pattern. So here this is a system. This is a model view MVC system where we have a model component, a view component, and a controller component. So the model component actually deals with all the database related operations, the data creation, update, and read functionalities. So that's why all those functionalities are being provided by the model component. The controller basically handles the logic, and it has the power to update or change the data, and the view component basically reads the data and shows it to the end users, and the UI component basically handles the data from the user. Suppose if we are providing any data to the system, that the UI component handles those. And so the parser component and the controller component basically depends on the data from the UI. So in any case, if there is a data provided from the UI, it needs to be parsed, or the new data needs to be created. So the parser handles that, and the controller handles any update related operations or on any update related data. Suppose a user is updating some data and the controller is handling those. So that's why there is a dependency relation over here. So these two components are actually depending on the UI component, the data from the UI component, and the controller component updates or change settings. These are the functionalities that it requires, and this update or change setting interface are being provided by the model component. And the parser actually deals with the data creation part. So in order to create data, it needs that create data interface, which is being provided by the component. Again, the view component is able to read data from the database, so it needs those interfaces to read the data from the database, and those interfaces are being provided by the model component over here. And finally, the display component is providing all the display related options to the view. So whenever it reads the data, it updates those data in the display component, so through this provided interface. Now if we look at the inner view of a model, so this part, so over here we can see that there are multiple internal components over here as well, and so here we can see that this whole thing is the model component, and over here there are multiple internal components which basically handles each functionalities that this model as a whole provides, or the interfaces that this model as a whole provides. Suppose we can see that over here the data component provides the create data interface, and it is being delegated through this port over here. And also the read data interface is being provided by this data component, and it is being delegated through this port over here. Similarly, the average component and the settings component are also providing those update average and those change setting interfaces to its external environment. And these are the interfaces that are being used by the controller and the parser and the view. So all this provider interface that we see over here are actually being provided from some internal components within that model, and each of these actually handles each part of the operations over here. Okay, so that is all. This is all the examples. We have looked at some examples, and I hope that clears out some basic concepts about component diagram. So component diagram actually, as we have already seen that from these figures, that we can actually get a high level overview of the whole system from each of the component diagram, and that is quite helpful when we are designing a system or a very complex system.